Welcome to clickmyproject.com. Here we described about the customized computer-aided application mapping on NOC infrastructure using multi-object optimization. In this project, chip microprocessor keeping increasing the number of cores on the chip. The network on chip technology is becoming essential for interconnecting the cores, while NOCs results in noticeable performance boost over conventional bus system. They consume a non-negligible fraction of the system power. In this paper, we propose a reconfigurable architecture for network on chip, which dynamically changing inter-router connections according to the traffic pattern. In NOC, the design of the topology plays an important role in minimizing the power consumption and hop count. In this paper, we propose optimization technique to generate a custom topology for inverse architecture. Inverse architecture apply a networking technique and technology to communication subsystem. In system on a chip design, inverse interconnection architecture have significant advantages over traditional non-inverse interconnects, such as support for independent layer design and optimization. Inverse interconnection architecture provide a number of significant advantages over traditional inverse interconnects, which allows for independent design and optimization of the transaction and transport layer. NOC links can reduce the complexity of designing ways for predictable speed, power, noise, reliability than a system design viewpoint with the advent of multi-core processor system. A network is a natural architecture choice. A NOC can provide separation between computation and communication, support modularity and IP reuse via standard Now we discuss about the system flow diagram. The system flow diagram represents the flow of our process. First of all, we give the input signal to the Tmax block. The Tmax block acts as a multi-bit generator. The multi-bit generator generates the different output. The different output pass into the FIBO. The FIBO block acts as a memory block. The memory block generates the output after the particular clock period. If generate the output, in case of clock period varied, our output signals are varied. Finally, the FIBO output passes into the crossover function. The crossover function acts as a multi-link property. The multi-link property generates the multi kind of output. The multi kind of output finally passes into the genetic algorithm. The genetic algorithm consists of four steps. The first step, selection process. The second process, mutation function. The third process, transfer condition. Finally, we give the output to the fitness function. The fitness function generates the very fitness function output. The fit function output passes into the TDM and ALU block. These two blocks are our application blocks. These are the kind represented our system flow diagram.
Now we are going to verify the first step. Please select the check senders. Now we are going to verify the syntax error of our program. In case of any error and warning is there, please show our console block. Now we have no error in our project. Now we are going to second step. Please select the view RTL schematic. In this process, generate the RTL schematic diagram. Please add and create schematic. This is our overall block. Select clock, enable read, enable write, reset spin. These all are the input signals. Finally, we got the fit 1, fit 2 output signals. This is our overall RTL schematic diagram. These all the blocks are generated. Now we are going to the third step. We generate the technology schematic diagram. Please select View Technology Schematic. In this step, generate the technology schematic diagram from our program. This is our overall technology schematic diagram. In case of you show you in full view, please select this. In our process have a larger number of LUTs and flip-flops. Now we are going to the final step. Please select the simulations. In this step we generate the simulation waveform. Please click simulate behavior model. Now we are give the basic input signal. Clock set to 0. Reset value set to 1. Spin set to 0. So enable read set to 0. Enable write set to 1. We give the select line. This is our run pattern. Now we are going to change our input value. Clock set to 1. This is our reset condition outputs. Now we are going to reset value to 0. Then set spin value to 1. Enable read set to 1. Enable write set to 0. Clock value set to 0. Then hand change clock value to 1. Then hand change the clock signal to 0 to 1, 1 to 0. Then set spin value to 0. Now change the clock value to 1. Please change the clock value up to we got the fit values, fit 0 and fit 1. Now we generate the mutation output signals, but we didn't get our fitness values. Please change the clock signals. Now we got the fitness value. Then again we change the clock signal, we get different fitness values. This is our running procedure of our project. Thank you.